Hello everybody, welcome to Easy Science. இந்த சேனல் பிடிச்சிருந்தா லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணுங்க, பெல் ஐகானை கிளிக் பண்ணுங்க. அப்போதான் புதுசா போடுற வீடியோஸோட நோட்டிபிகேஷன் உங்களுக்கு வந்து சேரும். Good morning. Today we are going to see part 3 of the lesson Laws of Motion. The topic we are going to see today is Principle of Conservation of Linear Momentum. The definition for this is there is no change in the linear momentum of a system of bodies as long as no net external force acts on it. Let us prove the law of conservation of linear momentum with the following illustration. Proof. So there are two bodies A and B with masses m1 and m2 with initial velocity u1 and u2 moving along in a straight line. Let the velocity of the first body A be higher than that of the second body B. That is, u1 is greater than u2. During an interval of time t second, they tend to have collision. Collision na modrudu. After the impact, both of the bodies move along the same straight line with a velocity v1 and v2 respectively. The force on the body B due to A is Fb is equal to m2 into v2 minus u2 divided by t. Here, the force is equal to ma according to Newton's second law of motion. Force is equal to ma. And the values are being substituted here as Fb is equal to m2 into v2 minus u2 divided by t. Force on the body A due to B is equal to force A is equal to m1 into v1 minus u1 divided by t. By Newton's third law of motion, we know that for every action there is an equal and opposite reaction. So Fa is equal to minus Fb. m1 into v1 minus u1 divided by t is equal to minus m2 into v2 minus u2 divided by t. And m1 into v1 plus m2 into v2 is equal to m1 into u1 plus m2 into u2. We get this by cross multiplying. The above equation confirms in the absence of an external force, the algebraic sum of the momentum after collision is numerically equal to the algebraic sum of the momentum after collision. Thus, the law of conservation of linear momentum is proved. Rocket propulsion. Rocket propulsion is based on the law of conservation of linear momentum as well as Newton's third law of motion. Rockets are filled with the fuel, either liquid or solid, in the propellant tank. So we see here two rockets. One is a liquid propellant and other one is a solid propellant. Here, the fuel that is used is liquid. So here lavender color thing you can see, and here this is the propellant tank, and this propellant tank, it is filled with liquid. And this is a solid propellant rocket, and this orange color thing here you see here is the solid fuel that is filled. So it is known as solid propellant. Okay. When the rocket is fired, the fuel is burnt and hot gas is ejected with high speed from the nozzle of the rocket, producing a huge momentum. Here also, after the fuel is being burnt, gas comes out through this nozzle at the back. To balance this momentum, an equal and opposite reaction force is produced in the combustion chamber, which makes the rocket project forward. While in motion, the mass of the rocket gradually decreases until the fuel is completely burnt out. Since there is no net external force acting on it, the linear momentum of the system is conserved. The mass of the rocket decreases with altitude, which results in the gradual increase in the velocity of the rocket. At one stage, it reaches a velocity which is sufficient to escape from the gravitational pull of the earth. This velocity is called escape velocity. Next topic, what we are going to see is Newton's universal law of gravitation. The definition says that every particle of matter in this universe attracts every other particle with a force. This force is directly proportional to the product of their masses and inversely proportional to the square of the distance between the center of these masses. The direction of force acts along the line joining the masses. The derivation for this is force between the masses is always attractive and it does not depend upon the medium where they are placed. So we see here two masses or two objects. They may be planets or stars with masses m1 and m2. There is a force of attraction acting between them, which is F1 for mass m1 and F2 for mass M2, and they are about r meter apart from each other. Let M1 and M2 be the masses of the two bodies A and B placed r meter apart in space. Force F is directly proportional to M1 into M2, or force is directly proportional to 1 by r square. On combining the above two expressions, we know that F is directly proportional to M1 into M2 by r square, or F is equal to G into M1 into M2 divided by r square. Here, the directly proportional sign is removed and equal to sign comes here. So as a result of it, the constant G comes here, which is a universal gravitation constant. Its value in SI unit is 6.674 into 10 to the power of minus 11 Newton meter square kg minus 2. Next topic what we're going to see is acceleration due to gravity. When we throw an object upwards, it goes upwards, and after some time the velocity ceases and it comes down. As it comes down, it comes with an acceleration, which is acceleration due to gravity of the earth. And this acceleration due to gravity of the earth, it is represented by the small g, and the units it's meter second minus 2. The mean value of acceleration due to gravity is taken as 9.8 meters second minus 2. This value may vary at different points. It may be about 9.6, 9.7, 9.9, 9.10, and that's why the mean value is given here, which is 9.8. The velocity of the body during the downfall motion varies 9.8 meter second minus 2 for every second. The value of G is not the same at all points on the surface of the earth. So the value of G, as already I told you, may vary in the polar regions, may vary in the equatorial regions. So on the surface of the earth, it may vary. The relation between G and G. Here we see that when a body is rest on the surface of the earth, there are two objects. This is earth of mass m. There is another object that is found on the surface of the earth. It may be a stone of small m, which is the mass, and they are a distance apart, which is r meter, and there's a force acting between them, which is denoted as F, and the radius of the earth is found to be 6,378 kilometer. Now, according to Newton's second law of motion, it says that F is equal to ma, and so a is acceleration due to gravity. So we denote it as F is equal to mg. According to universal law of gravitation, we get the formula F is equal to gmm by r square. Comparing the two equations 1 and 2, we get mg is equal to gmm by r square, or g is equal to gm by r square. This is the final equation we get from this derivation. Next one is mass of the earth. Mass of the earth is denoted by capital M. Mass of the earth is equal to g r squared by g. Substituting the values of small g, r, and capital G, we can calculate the mass of the earth. And the mass of the earth is found to be 5.972 into 10 to the power of 24 kg. The next topic is variation of acceleration due to gravity, and it is given by the formula G is directly proportional to 1 by r square. The geometric radius of the earth is maximum at the equatorial region and minimum at the polar region. So if you take the radius of the earth, it varies at different regions. So as we have learned in our lower classes, the earth is not just spherical as we learned, but it is in a geoid shape. So you can take the example of an orange. It is flat at the top and the bottom, and it is broad at the sides. The value of G is maximum at the polar region, and it is minimum at the equatorial region. The value of G reduces in higher altitude, and it reduces deep below the surface of the earth, and it is 0 at the center of the earth. Thank you. We can see the proceeding chapters in the next class.